Hello friends, today we are going to learn how to monitor your resources with Google Cloud Platform monitoring service or offering. What we are going to do is we are going to see how to set up monitoring, how to set up alerts, how to set up email notifications when something goes wrong, and we are going to do a hands-on demo. Most of the demo is going to be done using Terraform templates. So we are going to set up our basic lab using Terraform templates, and then from there we are going to build on top of what we just deployed using Terraform, and we will be creating some monitoring, some alerts, different types of health checks and things like that. So let's get to it. So before we jump into the demo, let's explore what the code looks like. So the code is very simple. We have a readme file that you can see here. This repository is public. The link for this repository is in the description, so feel free to explore that. In the readme file, you can see all the steps that we are going to follow, and if we look at the code, we have Terraform template called main.tf. This Terraform template deploys our basic lab. We will get through it in just a second. Then we have this thing, this file called app.py. It's a very simple one-liner HTML file which just returns saying, thank you for visiting the website. Your request's HTTP status code was 200. The reason I put sleep for the to create some latency is because I'm working on a different demo and I wanted to show you something else. But for now, just assume that it's gonna be a little slower, like less than a couple of 100 seconds. And this is our Terraform template. So let's go through the Terraform template. So the first thing we are doing is we are executing this environment.sh file. This environment.sh file just sets up the Google Cloud project as an environment variable which is exposed as a project. Then we just grab the default service account for our GCP project. So here is where the things really start. We are gonna create a brand new network in GCP. This part of the code does that. It creates a new VPC. Then we create two subnets with the CIDR range 10.0.0.0/24 and 10.0.1.0/24. Two subnets, one VPC, pretty simple. Then we create an instance template, and in the instance template we are specifying how our virtual machine should look like. Each virtual machine that comes up will have a tag called my awesome app server public, because it's a public service, public virtual machine. Each virtual machine will have Ubuntu operating system, and it will be part of the network that we just created up there in the first step. Then each virtual machine will end up with a startup script. This startup script really doesn't do much. All it does is it updates the operating system. It installs pip, git, and stress. And this part which I have commented, this part actually installs ops agent. Ops agent is a new agent that Google recommends we put on our virtual machines. And then we clone the git repository, we cd into the directory where we cloned it, we do pip install requirements.txt file, we run the Python and say app.py. So this will host our server. And then we assign the default service account, and then we create an instance group manager. This instance group manager will use this instance template. So we are going to create a managed instance group, and that managed instance group will use the instance template we just explained. and it is going to create a named port called my awesome app port, because that is the port, and it listens to port 8080. So this named port 8080 is the port on which our website will be listening to and running. Then we create a firewall rule. This firewall rule will allow SSH only from identity our proxy, which is in browser SSH session. So we will not be using our own computer to SSH into the system, but we will be using in browser SSH. The last thing you want to do is have your system compromised because you opened up port 22 to the world and everything got haywire. We do not want to do that, so we are restricting that only from in browser SSH session we can SSH into the server. Next thing we are gonna do is we are creating a backend service. So we are gonna create load balancer, and your load balancer requires backend service and health checks and front end and all those sort of stuff. So we are creating a backend service. This backend service has a health check. We will get to that again, but this backend service is actually listening or is pointing to the instance group manager we created right here. And here is the health check. So the health check is pinging on or is sending request HTTP requests on port 8080. So as long as it can return the response, our health check will pass. And then we create the target proxy, and this will be the target proxy, and it points to the URL of our backend service. And then we create forwarding rule saying everything that comes in, just pass it to the target proxy. This target proxy passes it to the backend service, and this is just random stuff. We are just outputting the environment that we actually just read here. So this is what our Terraform template does. In a nutshell, it kind of creates a lab which you will see mostly in your production environments, where you have few virtual machines hosted behind a few virtual machines that are part of a load balancer, and your requests are going to the load balancer, and from there they are going to the virtual machines. So this is a very pretty basic setup which resembles closely to what you see in production. So the next thing we are going to do is everything else is going to be going to happen in the GCP console. So let's go ahead and do that. Okay, now we are in the GCP console. So the first thing we want to do is we want to create a brand new project, so that later we can delete the project and not mess up anything that we are actually currently working on with. So we are going to name this project GCP monitoring demo, and we'll click on create. Go ahead and select the project. Make sure you are in the project that we just created. So by going through the instructions one by one, first thing we want to do is we want to enable the APIs. So we have to enable two APIs: identity and access management API and compute engine API. So come back to the project and search for APIs and services, and go to enabled APIs and services. Click on enable APIs and services and search for identity and access management IAM API. Click on it, enable that, and then we come back and we enable compute engine API. So search for compute engine API, select it, click on enable. Now it may take about a minute or something for this API to get enabled, so I will come back to it when it's done enabling the API. Okay, so our compute engine API is also enabled. So let's go back to our home page and see what do we need to do next. So we need to activate the Cloud Shell and we need to deploy the Terraform template. But before we do that, let's go to our VPC networks, and you see this default VPC network. Now you can leave it as is, no harm, no foul. But if you want to keep things, a little more tidy, then you can just go ahead and delete this VPC network. I strongly recommend you to do that only if you have created a new project. If you are working on something that is already deployed, do not do that, because you may have deployed something in the default network and it may not go very well. So because this is a brand new project, we are not going to use the default network. We are going to create our own network. That's the reason I'm deleting the default network. So let's go ahead and delete that. So our default network is gone. Let's look at the subnets and refresh them. No subnets. Let's go to the firewall. Look at the firewall rules. No firewall rules. So everything is pretty much gone. Nothing is there. Because we'll be creating everything that we need using Terraform templates, we do not need all this, and that way we can follow the principle of least privilege. You only create things that you need. Anyways, so let's go back to our the dashboard, and you see this icon here which says activate Cloud Shell. Go ahead and click on it. And what this will do is it will create a Cloud Shell environment for us, and this is where we will be working for the most part. Okay, now let's just increase the size of it, clear it out. The first thing we want to do is we want to clone our Git repository. So we come here, we copy the command and we paste it here, and our repository is cloned. Next, we cd into the directory where our Terraform templates are, and they are in a directory called IAC, infrastructure as code. So if you do ls, you can see that our main.tf, our providers.tf, all those things are right here. Next thing we do is we initialize Terraform, and then we apply the Terraform template. Authorize. Okay, now it's in the process of creating the resources that we need. So we just wait for it to finish and I will come back to it when it's all done. Okay, so as you can see, our Terraform template is deployed successfully. So let's go ahead and check things out, make sure everything is the way we want it. So let's start by going to the VPC networks. And you can see we only have one VPC network called My Awesome VPC network with 2 subnets, and these are the 2 subnets. Let's go to the firewall, and you can see we only have one firewall rule called allow ingress from IAP, identity aware proxy, on port 22 only from the IP range which belongs to the IAP IP range 35 to 40 0/20. So this is Google provided range. So every IAP SSH session is actually initiated by using this IP range. So if you do not allow this, then you will not be able to use in browser SSH. So make sure we have that done. Next thing we do is we go to compute engine, and you can see our compute instance is coming up, and let's go to load balancing. you can see our load balancer is created. The backend service is unhealthy. We will fix it. I know why it is intentional. All right, so just hold on, just bear with me. Go to backends. This is our backend service, which points to the is part of the load balancer, and this is our front end. This is our load balancer front end. This is the IP address of our load balancer. So when we hit this, it will give us an error right now saying that there is no healthy upstream. So let's go ahead and copy this address and paste it here, and it says no healthy upstream because our backend service is there, but it's unhealthy. The health checks are not passing, right? Everything is intentional. Next thing we do is come back to the compute engine, and click on it, click on the instance, and you can see there are two tabs, details and observability. So if you click on the observability tab, you can see the CPU utilization, network traffic, new connections with the VMs and all those sort of things. But here is what I need you to look at: memory utilization and disk space utilization. They are saying they require ops agent, and you can click on the install button here. We are not gonna do that, and what it will do is it will go ahead and install the ops agent on the virtual machine. We do not want to do that. It's just so you can do that as well, but we don't want to do that. And that's because we have not installed ops agent. If you remember, we have those lines in our startup script commented out. We are going to install this manually, but we will explore some couple of different ways to do that. So, and then here is our instance template. You can see this is our instance template, and if you look at the instance groups, this is our instance group that we created. And if you look at the health checks, this is our load balancer health check, right? It's failing, but it's going to the root and on port 8080, and it says I can't find anything over there right now. I mean, it technically is not able to reachable there, but we will fix everything. So so far everything is good. This is exactly how we wanted our system, our lab setup to look like. Our load balancer is there, but it's not working because the backend service is not healthy. So let's go ahead and see why that is happening. So the reason it is happening is because if you look at our firewall rules, we only have one firewall rule which allows ingress, SSH ingress, from this IAP range, identity aware proxy range. What we need to do is we need to create one more firewall rule which will allow inbound from the load balancer's IP range. Now you can just create a firewall rule which allows a whole wide world on port 8080, and that way you will not get the error saying load balancer is not reachable. Load balancer will definitely reach, but so is everybody else. We do not want people to directly go to our virtual machine. We want them to come to the load balancer, and the load balancer should be the only entity that should be able to access our web server on port 8080. So that is the reason why we have created that kind of lab setup. So go ahead and click on create firewall rule, and we are gonna name this firewall rule as allow on 8080 from load balancer IP range. Network, we select the network that we just created called my awesome VPC network. Leave everything as is, ingress and allow match. Targets should be the specified target tags, because every virtual machine that we are creating has this tag called my awesome app server public. We are saying that this rule only applies to the virtual machines which has this tag called my awesome app server public. Next is the source IP ranges. These IP ranges are the IP ranges of load balancer and health checks that run as part of the load balancer. So let's first put the IP address ranges here. Now, where did we get these IP address ranges? So if you go to this URL called external application load balancer overview, and if you scroll down all the way to a section called firewall rules, this is the section called firewall rules. You can see that it has this load balancer mode and the source ranges. So it says that if your load balancer is of type global external application load balancer, our load balancer is global external application load balancer, then the source for the health checks will be these IP ranges, and the requests will be coming from these IP address ranges. Same way, if you're creating a classic load balancer, then these are the IP ranges, and if you're creating a regional external application load balancer, then these are the IP address ranges. Now, right now, these IP address ranges for the health check and the source request source are same. In future, they can change, but these are the IP address ranges that we have specified here, saying that if the request is coming from these IP address ranges, then only allow the request to go through, otherwise don't. That way, if somebody else tries to reach our virtual machine because they have an external IP address, they will not be able to get to the website. They can only get to the website if they are hitting it with the load balancer. Next, we specify the TCP port, and the port is 8080, and we click on create. Now that this is created, let's go back to our load balancing and see what happens. Now, pretty instantly, our backend service comes up as healthy, because now the IP address ranges from where the health check is coming from, they are allowed to reach these virtual machines. And now if we go back to our front end IP address and we refresh it, it still is gonna tell you no healthy upstream, but give it some time, about a minute or two, and it will catch up. So let's just wait for a couple of minutes, and when it's done, I'll come back to it. Okay, let's try to refresh it one more time, and you can see that now our website is up and running. It says thank you for visiting the website, your request's HTTP status code was 200. So now our load balancer is able to talk to the virtual machines, but if you directly try to go to the virtual machine, go to compute engine, and if you grab the external IP address and you say, hey, I know your IP address for the virtual machine, I will directly just go there on port 8080 because I know that's where your website is listening. And if you click on it, you will not be able to reach there, because we have restricted the ingress only from the load balancer IP address. It's gonna time out, you can wait for it, but that's what's gonna happen. So now that everything looks good, now we get to the part where we set up the monitoring, right? And before we do that, let's go ahead and install the ops agent. So let's go ahead and do that. Okay, now as you can see, when we go to observability tab, it says it needs ops agent. Same thing, if we go to monitoring, search for monitoring and go there, and it will present you with this welcome page, and it says install an agent. And if you click on setup agents, it will tell you, it will show you the virtual machines. It will show you the virtual machine, but it will say that there is no agent detected because we haven't installed anything. And what you can do is you can select this virtual machine and click on install or update agents, and it will give you this command that you can just copy and paste it in the Cloud Shell, and it will go ahead and you can paste that command in the Cloud Shell and it will go ahead and install the agent. We do not want to do that either, right? So that's one way of doing it. You can do it that way. We are not gonna do that way. So what we will do is we will go to the compute engine. The best way to do that is to do the automation. So if you just uncomment these lines here, then these will become part of the startup script installation process, and anytime a virtual machine comes up, it will have the agent already installed on it. That is the best way of doing it. And what we are gonna do is we are gonna go ahead and copy this particular first command, and we are going to SSH into the server. So you click on the SSH, and this will initiate in browser SSH session, and just wherever your home is, just paste that command, press enter, and then let's grab the second command, which is going to install the agent. Copy that, paste it. Okay, now that our agent is installed, let's go back to the VM instance and click on it one more time and click on observability, and slowly it will figure out that there is an agent installed, and this require ops agent install. This will go away and it will actually start to show us the data. So let's wait for a couple of minutes for that to happen. Okay, as you can see now, the system has detected that there is an ops agent already there. So it is starting to show us the data for the memory and disk space and everything. Same thing if you go to monitoring, it instead of asking us to install the agent, it says you already have an agent installed. So if you click on the setup agents, you can see that the agent, it says you have an ops agent. Now sometimes you will start to see it will say legacy agent, and then after a while it will catch up and it will figure out like, nope, it's actually an ops agent. So if that happens, just wait for a couple of minutes and you will start to see that it has an ops agent. Now our agent is installed, so we can grab the metrics like CPU utilization, memory utilization, disk space utilization, all those fun stuff, all the fun metrics. But let's see what next we are supposed to do. Now we will go and set up our monitoring. So what we are trying to do is we want to get notified if our web server ever goes down, right? So that right now we only have one web server, right? So if our web server goes down, our website is down. You may have 2 virtual machines, you may have 5 virtual machines. So if all your virtual machines suddenly go down, your website is down, right? So what we do is we are gonna stay in the monitoring tab, monitoring section, and we are gonna click on something called groups. So click on the group. So instead of creating a check on individual instance, we are gonna create a group for the instances, right? Because our instances are ephemeral, means they may come back, they may go down and the new instances will be created and replaced, right? And they all may have different IP addresses, different names. They are not deterministic, right? But the only thing that is deterministic in all of those servers is the tag that we have given them. So let's create a group. What we are gonna do is we are gonna say, let's create a group called My Awesome App Servers. And the criteria for the virtual machines to be part of this group is tag, and the tag will be app name, and the value will be my awesome app. So what we are saying is there are virtual machines which has this tag called app name, and the value of the tag is my awesome app. Only those virtual machines should be part of this particular group. So once you put all these things in here, you will notice that it says 1 VM instance currently selected. But if you change something, it will start to say no resources match your selection criteria, because our tag does not match with the one we have on the virtual machine. So that's the tag we have on the virtual machine. For the app name, it's my awesome app. Click on done, and then click on create. Now you can see that you have one VM instance. It is showing up here, and these are the key metrics and charts and everything, CPU utilization, received bytes, sent bytes, and read bytes, and all those fun stuff, right? So you can just explore all these if you want to. But now that we have created our group, the next thing we want to do is we want to create uptime check based on the group. For that, go one up where it says uptime checks and click on create uptime check. And the protocol for the uptime check will be HTTP. Resource type is not going to be the URL. Now you can put the URL in there, and then you put the URL of your load balancer, and that will work too. But we want to make sure that our virtual machines are good, right? So that's what we are trying to do. And so we select the instance as the resource type. Now what does it applies to? Does it apply to a single instance, or does it apply to the group? If you say single instance, you can select one or more instances from here. Not one or more instances, you can select an instance from here. But our instance, even though right now it is one, because that's the way we have set it up, you can easily create 2 or 3 or 4 virtual machines as part of your managed instance group, and then it's not gonna work, right? So what we do is we say we want this to apply to the group, and we select the group that we just created, and we say the path is gonna be / because that's where our website is running. And then in the port, we select 8080. We want it to fire a GET request on our virtual machine IP addresses and on port 8080, and we click on continue. Request timeout is good, response codes are good. But one more thing here is that it asks you that how frequently do you want to check. So we are gonna say check it every 1 minute. Fire this uptime check every 1 minute. From where you want to fire. So if your website is only going to be used by, let's say, people in Europe or in United States, then you can restrict these health check origination regions to only Europe, or maybe only United States. You need at least 3. So if you select less than 3, it will tell you that you must have at least 3 active locations. So we have 3 active locations in United States, 1 in South America, 1 is Europe, 1 is Asia Pacific. But if your website is global, people from all over the world are gonna be reaching to your website, then you select the global, and the health check will be performed from all these locations, saying, can your website be reached from Asia? Can it be reached from Europe? Can it be reached from South America? Can it be reached from United States, right? So that's the global, or you can restrict it to few locations. And then we click on continue. So we are going to say our request timeout is 10 seconds. We do not want to specify anything else. We do want the checks failures to be logged. What is the acceptable HTTP response code? So when the health checkers, when they fire the request, which response code classes should they consider as successfully reached your application, right? So we are saying that as long as they get anything in the 200 range, so 200 is okay response, 201 is also okay response, as long as it is anything 200, we are okay. Now you can also say that, hey, I also want my redirects, my 301s to be there too, or if it is 401 unauthorized, it's not, the request is not authorized, but the health checker is able to reach there. I want it to be considered successful, right? Then you can select all these codes. But for now, we are going to say that only if you receive the response code anywhere in 200 range, you're good. If you want to restrict it to a request, a response code, like if it is 200 only, then only allow it to be successful. If you receive 201, then it is not successful, then it will fail the health check. Or you can say allow any response code, as long as you get something, you're okay. We want to select 2xx, so anything in the 200 range, you're good. Click on continue. Define uptime check alert condition, so we want to disable that for now, because that is the next thing we want to do. Just disable that for now, and click on continue. And the title is going to be this one, my awesome app instance level uptime check. Now let's go ahead and test it. When you click on test, what it will do is it will just make sure that your servers are reachable, they can be fine and everything. Now this test is going to actually fail. Why? I'll tell you. So right now it says that our hosts are unreachable, right? We say for now it's okay, we still just go ahead and create it. Now the reason these hosts are unreachable is because we have not allowed the communication from the checkers, uptime checkers, to our virtual machines. Remember, we only have created firewall rules which allow SSH from identity aware proxy and communication on port 8080 from the load balancer IP range, not from the uptime checkers IP range. So what we will do is, first we will see these health checks are start to gonna fail. We would like to see that, and then we are gonna fix it and see how that looks, and then we will create the email alerts and everything. So let's wait for the health checks to start failing and see how they look like. Okay, so it has been a while since we created the health check, and if we refresh the page, we should see them all failing. You can see that they're all failing, saying all checks are failed, and from Asia Pacific, from Europe, from North America, from South America. And if you click on the health check, it will tell you that it is failing from Virginia, Oregon, and Iowa. These are the regions or locations within United States or within North America that the health checkers are firing from, request firing from. From Europe, they're firing from Belgium. From Asia Pacific, they're firing from Singapore. From South America, they're firing from Brazil, Sao Paulo. They're all firing, but nobody is able to reach our instances because we have not allowed the communication, right? There are other things here that you can notice. One is the check ID and the title and port and everything else. So how do we allow the communication from uptime checkers to our instances? Now we do not want to allow the communication from everywhere, right? So if we create a firewall rule to allow communication from 0.0.0.0/0, it defeats the whole purpose that now uptime checkers will be able to reach, but so is the whole wide world. We do not want to do that. So what we do is we want to get the specific IP ranges. So if you look at this download button here, if you click on that particular download button, it will actually download a file called Uptime source IPs, and I have actually already downloaded that file, so that's why it is showing as a 1. So I'm gonna click on save, and then we open that file, and you can see that this file has all the IP address ranges that it has, showing that from South America, Sao Paulo, it is firing from these IP ranges. So if you want to restrict only for the requests to come from South America, you only need to allow communication on port 8080 from these IP ranges. Now because we have allowed it to be from the global location, we need to whitelist or allow the communication on port 8080 from all these IP addresses. If it was just for Europe, then this is the only section you need, and these are the only IP ranges you need. Now let's go ahead and create this firewall rule which will allow the communication on port 8080 from all the IP address ranges. So here is the IP address ranges. I have created them as a comma separated list, and go ahead and create this IP address range. So the first thing we are going to copy is the name. So let's go to firewall, click on create firewall rule. We are going to name it allow on 8080 from uptime checkers. We select the network. It's more or less the same as what we created last time, just the only difference is gonna be the IP address range. Select the target tags, and in the source IP address ranges, copy the entire thing. Because we said our uptime check is going to be coming from global locations, we are whitelisting all the IP address ranges. If it was just for a particular region, then you only need to allow communication from the IP addresses of that particular region only. And that's pretty much it. We select TCP on port 8080 and we click on create. Okay, now that our communication is possible on port 8080 from uptime checkers, we are going to now wait for a few minutes, and soon enough all these red dots will start to become yellow and then they will become green. And so let's just wait for them to do that. Okay, now it has been a while since we created the firewall rule, so let's go ahead and refresh the page. And you can see all of them are now green, right? So if you click on it, it will tell you that the health checks are passing from America, Europe, Asia, South America, everywhere, right? That is what we wanted it to do. Now we can go ahead and set up the alerts so that in case if something goes down, we get notified, right? So let's go ahead and see what we need to do. So we need to update the notification channels to have our email address added in there so that when something goes wrong, we can get the notification. So for that, let's go to alerting, same tab or same section, monitoring, and click on edit notification channels. and scroll down, and in the email, go ahead and add your email address. I'm gonna add my email address. And I'm gonna display name my email address. This can be anything as long as your email address is correct. Click on save. Okay, so we have created an email address and added that to our notification channels. Next thing we need to do is we need to create the alert. So come back to alerting and click on create policy, and in select a metric, click on VM instance, scroll down all the way. You should see something called uptime underscore check, and select on check passed and click on apply. And then in the filter, click on add a filter. So the filter is going to be the check ID that we just created, and we're gonna say equals, and this is gonna auto populate. So just select the check ID that we just created in the previous screen, on the previous screen. And the rolling window, you can leave it for 5 minutes or you can change it to 1 minute, doesn't really matter. Click on next. The condition types, so is it a threshold condition type, or is it a metric absence condition type, or is it a forecast? What we want to do is we want to say that if you do not get any data being put into the health checks from anywhere, then fire this particular alarm or trigger, right? So for that we are going to say metric absence. So we are saying that if you do not get this particular metric, for about a minute, then fire this alert, create incidents, and notify people on the email list, right? So that's what we will do. We will select metric absence, alert trigger anytime the series violates. Trigger absence time, you can leave it 5 minutes or you can say custom, and the custom value is 1 minute. So if for 1 minute, if there is no communication or there is no metric being put, then we will have to then we get the notification. Click on next. Use notification channel, yes, this is the notification channel we just created. Click OK. And incident auto close duration 7 days, means if for 7 days the incident is open, just close the incident, right? And you can add some text field saying that whenever somebody gets this notification on their email saying VM instance check is pass is failing, how do you resolve this? So it should be like restart VM instance, so that when your operations people when they get this alert, they get a documentation along with it saying that when this particular problem happens, how should they resolve it. Restart the VM instance, do something XYZ, or whatever they want, whatever you want them to do. And then we add a name to our alert policy. So that's my awesome app alert policy. Next, we are going to review everything, looks good, and we click on create policy. Okay, so you can see right now everything is good. There are no incidents created for this particular policy, and everything is looking good, so we don't get an email right now. But let's try to generate emails. Let's try to create problem for ourselves, right? So for that we go to compute engine, and we select this particular instance and we click on stop. Now remember, we created this instance as part of managed instance group, so at some point of time a new instance will be created, but because we specified the threshold time for 1 minute, it is gonna take more than a minute for this particular new instance to come up. So this will generate the alert policy. It will actually fire emails, and we should be able to see those emails in our inbox. So let's just wait for it to happen. So right now it is stopping the VM, and we click on uptime checks, and slowly all these uptime checks which are green, they're gonna start to turn red. Okay, now our VM instance is stopped, and our uptime checks, let's refresh them. Okay, now all of them are red because we stopped the virtual machine. So so all the health checks are failing, right? Now if you go to alerting, you will start to see that the incidents actually gonna show up. But if you click on uptime check and you click on it, you will start to see these, past checks going from 1 to 0 and then nothing. So let's just give it about a minute, and we should see the incidents being created over here and us getting emails. So now you can see that system has caught up saying there have been, there is an incident, and right now it is only showing 2, but slowly it is gonna show us 5 or 6 incidents being created here, saying system is not able to reach particular virtual machines in a specified time frame. So that is about it. Now if you go and check your email, you should be able to see that particular email with the subject and everything. So that is about it. So this is how you set up monitoring and uptime checks and everything, and this is how you get the alerts. So I hope you enjoyed the demo, and I will see you in the next one.